Yeah, so talking a little bit more about Blender, but coming at it from a different angle. So today I'm going to give a quick rundown of the workflow that I've come up with for mapping spatial data using the geometry nodes tools in Blender. I'm not really going to get into the weeds of sort of working with the interface, but instead I'm going to give a general overview of the steps that I've found helpful to bring data into Blender and then set up a basic visualization system that you can then build on and expand on. And I'll be linking to some sample files and some documentation at the end of the presentation if you want to explore further. I'll also upload the presentation to Slack as well. So what are geometry nodes? They're a new-ish tool for procedurally generating, modifying, and animating geometry within Blender using node-based operations. It's in sort of the same family of visual scripting tools as something like Houdini, Blueprint in Unreal Engine, or something like Model Builder in ArcGIS. It's sort of designed for generating these like geometric patterns or for like simulating physical forces, so like erosion. And it's usually you start with like a random seed or like a noise texture and then use that to like generate and modify geometry. But we can also bring in our own data to drive these visualizations. To do this, we'll need some data to work with. As an example, I'm using a CSV file of recent earthquakes from the USGS. We have to make a couple of changes to the table before it can come into Blender because there are only certain data types that it'll accept. First of all, we can't have any fields with text. So we either need to remove them or map them to numeric categories that we can refer to later. The other change we need to make is to the date. So instead of having a date, we want to have a timestamp that says like what frame of our animation do we want each event to appear on. The easiest way I've found to do this is to start with 1 for the earliest event and then pick like a round unit of time to like increment by, depending on like the time scale of the data that I'm mapping. So for this one, because it's about a year of data, I figured 1 frame would be equal to 1 day. And this also works out kind of nicely because if we're animating at 30 frames per second, then 1 second of the animation is going to be about 1 month of time. And then depending on the length, you can do like an hour or a week. An hour is also nice because then it's about 1 second for 1 day. To bring the data into Blender, we run a Python script. I wanted to do as little actual coding as possible for this, so I made it as simple as possible. I'll also link to that. And what the script does is it creates a new object in Blender. It creates a point within that object for every row of the CSV, and then it assigns the fields from the CSV as attributes that we can access with geometry nodes and use to drive the symbology and drive the animation. And that's what this looks like when we bring it into Blender. In the bottom left, we've got the default geometry node tree with an input that lets us access the attributes. So we have the magnitude, the frame that the event occurs on, and the longitude and latitude. And then an output node, which is what's going to be drawn in 3D space. And then everything that we do is going to happen in between the input and the output. And that geometry thread at the top is what's going to follow through and carry the data through the tree. On top, we have a little table showing the data that we've brought in. So we have all our fields, and then we also have this position attribute. So that contains the x, y, and z coordinates of each point. Because we didn't define it when we brought it in, they're all set to 0, and that's also why we can't see anything in the 3D view on the bottom right. So the first thing that we're going to do is take our latitude and longitude values and then combine them into this 3-dimensional position. And that's what that looks like when we've applied it. Because this is 2-dimensional data, because there is an elevation, the z value stays at 0. But you could also do 3D visualization with that as well. So the next step is to create a couple of new dynamic attributes that we're going to use to animate the data. One of the cool things about geometry nodes is that we can pull in information about our scene in real time and use it to create new attributes that update every time a new frame is drawn. So the first one, so if we take the current frame that the animation is on and then subtract the event frame attribute that says when each one occurs, we get an age attribute that tells us how many frames have passed since the point first appeared. If it's a negative number, it means the event hasn't occurred yet, and then a positive number is, in this case, how many days have passed since it occurred. The other attribute I want to create is a filter. And so this is a query that's going to return a true or false value to the question, is the point visible on this frame? I want the points to be visible for about a second, so I'm going to say that the filter is true if the age is greater than 0 but less than 30. We can also chain this condition. We can chain other conditions to the filter if we want to build out a more complicated query. So if I only wanted to see earthquakes with a magnitude greater than 6 in the northern hemisphere, I can add those conditions, and then the filter's only going to be checked if they're all true. Right now, nothing is changing in the 3D viewport because these are still one-dimensional points. We need to assign some geometry to them and then also apply the filter. And this is what it looks like if you play through the animation. You can see the age ticking up, and then when it hits 0, the filter gets checked, and then unchecked when it hits 30. So it's happening as the animation plays back. Yeah, and then so to instance geometry, we pick a shape. I'm just using a sphere. And then we say, for every point, draw this geometry. And then we can also apply the filter. So now we'll have a sphere that appears, persists for 30 frames, and then disappears. And then finally, I'm going to create a default material, change the color, name it points, and then pass the geometry through that so that material gets assigned. So that's how we can set the color and the different material properties of it. Also, finally, we can add a base map. This is just an image of a world map with an equal rectangular projection, and then it's just imported as a two-dimensional plane and lined up with the points. And this is what that looks like when it's all put together. So the points appear, persist for about a second, and then disappear. And this is what the whole setup looks like. So we have our input and output on either side. We're storing new attributes, then we're assigning geometry to them, setting a material, and then it goes to the output. And this is the foundation that we can start building on to vary the symbology and change up the animation. So what now? Every aspect of the object's appearance can be driven by any combination of the attributes that we've brought in. So we can build on that foundation and just start experimenting, just start plugging our data into different parameters and see what it does to the visualization. So first we can try scaling each instance based on the magnitude of the earthquake. This is kind of where a bit of an asterisk with this tool comes up. Because it isn't a visualization tool, it isn't designed as a data visualization tool, it's not considering how to accurately represent the data. That's entirely an exercise for the user. So if you plug the magnitude right into the scale, it's going to scale the diameter of the point. But we probably want, because we're looking at it from above, they're being visualized as a circle, we want it to be the area that scales. So we have to do the math ourselves to transform that. If you were looking at it from a 3D angle, we might want the volume to change. So that's something to keep in mind. Sometimes I'll do the visualization in a GIS program sort of in parallel to it to make sure, and then compare and make sure it's looking, that it looks right. We can also animate any aspect of the visualization using those dynamic attributes, the age and the filter that we created. So let's take the point scale that we made in the previous step and then multiply it by the age of the point. So now the points will appear, grow for 30 frames, and then disappear. We can do the same thing with any of the material settings too. So we can bring any of those attributes into the material editor and use those to drive any part of the appearance, so the color, the opacity, and so on. So this time we're going to take the age value again, invert it, and plug it into the opacity of the material. So now as the age goes up, the opacity is going to go down, and the effect being that the points are going to fade out over time, and it makes the animation a little bit smoother. Finally, let's take one of the original data fields, the magnitude of each earthquake, and use it to vary the color. I passed the magnitude through a color gradient in the material settings, so now we have a data-driven color ramp. And then for this, I also used the magnitude and the age values to set an emissive value to the material, so it emits light. And so this way, each earthquake appears with a flash and then fades out. This might be a bit much and start to sort of impede comprehension of it, but it looks kind of cool, and it shows like some of the variety of visual styles that the tool is capable of. And from here on, it's sort of the sky's the limit. It's really just a matter of experimenting with different nodes, seeing what happens when you plug them into the tree, driving different values with different variables in the data, and then it's a lot of that playful experimentation that we were hearing about earlier. one of the things I really like about this tool is it's really, really quick, too, because Blender's designed for 3D modelers and animators who are working with meshes with like millions of polygons and like really complex like image textures and physics simulations. If you give it like a few thousand points, it has absolutely no trouble doing it, and it's pretty much in real time, so you get this instant feedback. Even as you're playing it back, you can play with sliders and see the visualization change. These are some of the experiments I've done with it in the last few months, and most of them are just these really simple transformations that are stacked on top of each other. So on the right-hand side, those are just points where the z-axis varies with age. So as each point gets older, it floats up off the map. The top left is points that are offset horizontally by age and then vertically by a data value. In this case, it was COVID cases, state by state, and then those points are connected into a line and then have a material assigned to the line. So you get a neat sort of like animated spark line. And then for the wildfire visualization, it was the wildfires in Canada last year. Again, that's just varying the color and then the emission. This time it's the age and the intensity of the infrared light that each hotspot was giving off of. So you can get like a nice sort of fiery effect with that. The other thing I really like about this workflow is that because it isn't a data visualization tool and it doesn't do anything for you, like there are no black boxes, you have to be kind of decisive about like how you have to understand each step of the process, and I find it a really like helpful way to like think while working with data and to sort of understand every step that goes into making the visualization and to like be really thoughtful about the process. The other thing that I really like is that it's really modular. So groups of nodes you can collapse into groups that can be shared between projects. So it's really easy to start like building a toolbox of styles and visualization methods that can just be plugged into new data sets. And yeah, so I've linked to a GitHub page where I've got the sample file from this presentation. I'm hoping to have some more documentation and tutorials written up. I definitely encourage you to play around with it. I've had a lot of fun, and I feel like I'm just like barely scratching the surface of what the tool is capable of. It's also being updated very frequently, so there's lots of new stuff coming with every Blender update. It happens a couple of times a year. Yeah, so thank you very much.